Hey everyone, this is just a reminder video of what we have done in class this past week during our in-person time. So first off, we're looking at a system of equations. We've got two equations. These happen to be in standard form. I know that because the x and the y are on the same side. And so our goal is to solve this by graphing. And so what that means is to find the intersection point. It's not just to graph the two lines, but it's to find the actual point where they intersect. Okay, so what we have to do is we have to graph both of these equations. So let's call this equation A and this equation B. If you want to take a minute right now and pause and try it on your own on a piece of scrap paper and then come back to this video, press play, you can do that, or you can just watch it, whatever works. So if I'm going to think about graphing A, because this is in standard form, I can do one of two things. I can choose to rearrange this equation in y-intercept form, or I can choose to do intercepts. Okay, so for A, I'm going to do rearranging it into y-intercept form, and then for B, I'll do it the other way. It's really up to you, but making sure you're familiar with both forms is super important. Okay, so 8x plus 4y equals 16. So if I'm going to rearrange this in y-intercept form, I have to get the y all by itself. And then I'm going to divide both sides by 4 to get y all by itself. And I get y equals negative 2x plus 4. I'm going to make that negative 2 over 1, so I remember my rise over run. So my first step is going to be to plot this point right here. So I'm going to go 1, 2, 3, 4. Right, this is the y-intercept, so I'm always looking at where it crosses the y-axis. And then I'm going to use my slope. If I have negative 2 over 1, that means that's my change in y over my change in x. So I'm going to go down 2 because it's negative, 1, 2, and I'm going to go over 1 because it's positive. And I'm going to keep doing that a little just so then I get some nice points to connect. I do not have my ruler with me, so instead I'm going to use a piece of cardstock that I have near me, and that's fine too. The side of a notebook, lots of different things can work as your straight edge. Whoops, that can happen, but oh well. Okay, so I've got my line. Nice. Now I've got to do the other one, okay? So for B, I'm going to go down a little. For B, I'm going to take the equation, ax minus 4y equals 16, and I'm going to do it using the other method. So I'm going to find my intercepts. So this is going to be where it is on the y-axis, or my y-intercept, and this is going to be where it crosses on the x-axis, which is my x-intercept. Okay, so for this one, I'm going to plug 0 in for x. Eight times 0 is nothing, and I'm left with negative 4y equals 16. I'm going to divide both sides by negative 4, and I get y equals negative 4. For this one, I'm going to plug 0 in for y. That's nothing. When I divide both sides by 8, I get x equals 2. Then what I'm left with is 2 points. Remember, these are my x values and these are my y's. So I'm going to go over 0, down 4. Over 0. Oops, let me go back up. Over 0, down 4. 1, 2, 3, 4. And then I'm going to go over 2, up 0. Over 2, up 0. And then I'm going to connect those 2 points. I'm going to extend it. It's my dog roaming around. If you can hear her little collar jingling. Okay, so remember, Our goal was not just to graph these. Our goal was to find the intersection point. That's where they're crossing each other. And so if I look at what that point is, I'm going to go over 2, and I'm going to go up 0. And so my intersection point is 2, 0. That's the solution to that. Okay. Now, if we do a different kind of problem, the other type we looked at was solving inequalities by graphing. So to solve an inequality by graphing, we're actually going to find the region that works for both equations or both inequalities. Okay, so same thing. I'm going to call this A and this B, and I'm going to take a minute to graph both of those. So if I look at A, this is going to be a dotted line, and it's a dotted line because if we're less than or greater than, we have a dotted line. If we're less than or equal to or greater than or equal to, we have a solid line. So this first one's going to be dotted because we're greater than, and this one's going to be solid because we're greater than or equal to. Okay, so then I'm going to take A, and because that's in standard form, I'm going to solve this by using intercepts, and you're actually going to see how nice this one is when you do that. If I take this equation, and I can actually, just for right now, ignore the fact there's an inequality. If I plug 0 in for x, I get y equals 5. If I plug 0 in for y, I get x equals 5. See how nice that was for this one? Sometimes it's a little more work, but not for this. I'm going to plot both of these points and connect them. Over 0, up 5. 1, 2, 3, 4, 5. Over 5, 1, 2, 3, 4, 5, up 0. And then I connect them. And remember, it's a dotted line. Oops. Do it in pencil. You can do a solid line and then erase. Some people really like to do that. Okay, some of you have seen me throughout these classes kind of mess up if I try and do too much. So right now what I'm going to do is I'm going to do my test point for A. So for A, if I look at x plus y is greater than 5, well, I'm going to use 0, 0 as my test point. So if I plug that point in and I simplify, is 0 greater than 5? Well, no. And so if the answer is no, it means don't include the test point. So there's my test point. So I'm not going to shade that side. I'm actually going to shade the other side. Okay. Now for the part B, this one's in y-intercept form, so why not use that, right? So now I'm going to go down to 4 because that's my y-intercept. 1, 2, 3, 4. And then my slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. You can keep going as far as you want. And remember, we already determined that this one's a solid line. And so I'm going to connect the points. And now I have to figure out for B, my test point. So my equation for B is y is greater than or equal to 2x minus 4. 0, 0 still is a great test point because my line isn't on it. So I'm going to plug that in. 0 is greater than or equal to, that equals 0 minus 4. Is 0 greater than or equal to negative 4? The answer is yes. So that means we include our TP, which is 0, 0. So there's 0, 0. I'm including my test point. And so this is the side I'm going to shade. Okay. But remember, Our goal is to find the region that works for both inequalities. That's going to be the region that's shaded by both. So that's this region right in here. You can do that with a highlighter. You can do it with a pencil. I chose to use a pen today, maybe not my best choice. Okay. Those are two examples of what we did in class. Feel free to rewatch, pause, and that can be a really good way to get a review. Thanks, guys.